This video is supported by Neogen. More about them later in the video. Hello everyone, welcome back to the Genomics Bootcamp. Today we will return to the structure software and one of the most frequently asked questions on the channel, and that is how to determine the number of subpopulations, or the so-called k-value, from the structure software. Now, the previous answer was to use the so-called structure harvester. So this is the website for the structure software. And as you see, so there is a structures harvester here, which is basically a website, or was a website, which allowed an easy determination of this k-value. Now, the problem is the website is for some time now down, unfortunately. So what are the alternatives? Well, the good news is that the author of this structure harvester also uploaded the Python scripts that do exactly the same as the website did. So basically what we will do within this video, we go through exactly this approach, and we will use this Python script to determine the k-values for our structure run. Before we do so, there are a few things that we should mention. So when I was researching this topic a little bit, so I came across this Google Groups website that actually asks or discusses exactly this topic. And actually also the author of the structure harvester was chipping in with some very useful information. So if we go through his comment in detail, or well, it is a quite a long comment, so maybe just the main parts. But most importantly, right at the beginning, it states that in order to run the evano method, which is actually the core of the harvester or the structure harvester, you need to have a continuous series of k-values, all with the same number of replicates. So this is very important because, well, in order to do this, then well, you need to run the structure accordingly. So we will do so and do a kind of a sample structure run also in this video. So I will show you how to do it the most efficient way. But anyway, so this is the main thing that you need to keep in mind, that you need to do replicates, and you need to do the same number of replicates each time for each k-value. So again, it underlines, or the author underlines here, that if you skip k-values, or if you do different number of replicates, well, this script will not run because of how the evano method is interpreted in the script that we are going to use. So I will put this link also to the description of the video, so you can go through this and perhaps also other comments in detail. So it gives some detail about the calculations, but there is one more quite interesting point here that, well, you should consider. So the thing is, or number one, in any case, it's always useful to run the structure, or, well, any admixture analysis by that standard. You should run it with the k equals 1. So basically no admixture, or no subpopulations. So this is to test that actually if there is any structure in your population at all. So it might seem counterintuitive, but definitely it is something that should be done. Also, in the other hand, you need to, or, well, it's advised to run a bit more k-values than you expect to find. For example, if you have a data set, for example, we will have a data set that has two populations and one supposed crossbred population. So we expect to find relatively low number of subpopulations, or the best k-value should be quite low. But still, running for more k-values tests for situations when there is an unexpectedly large number of groups that we should consider. So before we go to the structure harvester itself, or the Python script anyways, so we run the structure itself. Here I have already the loaded data set of the goat data of the small East African and the Alpine goats and crossbred as it was analyzed in the previous video that showed the general use of the structure software. So if you are starting just now and you don't know how to load the data and what are the details that you need to consider, so I would suggest to pause this video and look at the structure introductory video first, so you can actually get to this stage. So we have the project data loaded, and now we want to run structure. The first thing that you need to do is to create a parameter set for the runs. Here I have already some that I used before, but let's say that you are just starting, so you don't have any. So then you can create it easily by clicking the parameter set and creating a new parameter set from the top banner. Now, here, what we need to set, well, you can set many things, but for this particular example, we will set only the burn-in period and the number of MC iterations after burn-in. Now, there is a bit of a, well, downside, I would say, of the structure software, that it takes quite long to finish. So it's a deep, well, if you want to do a proper analysis, you need to set a quite high number of iterations in the thousands. Here, or well, if you want to do this test, then you need several replicates. So expect a longer runtime. Well, of course, considering the size of your data, but if you are dealing with SNP data, then well, this runtime could be considerable. Here, for the purposes of this example, we will set just a very low number of iterations, so it just finishes quickly. So and then I can proceed with the demonstration. But for the proper analysis, please check on the papers that were published on this topic, and well, try to see what are the numbers of iterations that I use there. So I don't have it right now in mind, but what I know that these are definitely in the high thousands. For now, we would set, let's say, 50 burn-in and let's say, I don't know, 200 for the MC rep. So this is way too low. So this is really just for the demonstration. We click OK, and we name this parameter set. New set for K value demo. Let's put it like that. Okay. So we have our parameter set that is also active. So we can now proceed with the actual analysis. Now, if you want to do just a single analysis, you can click this exclamation mark here that says run, and you can set the number of populations assumed. So this would be this K value. Doing it manually for so high number of K values, and especially so high number of iterations, would be time consuming. Fortunately, there is a better way. So you click project here on the top side and click start job. This actually does open a smaller window where you can actually set a number of K values from 2 and also the number of iterations. Also, you need, or you don't need, but you can set the so-called starting seed numbers. This is very useful if you want to exactly replicate some runs, but for us, this is not important right now. So you need to select parameter set to use. So we will use this new one that we have just created. And let's say we start from K equals to 1 to, let's say, K equals 5. And we will do, let's say, 5 iterations each. I think there is a minimum of 3 iterations each that you need to do for this Evano method. But of course, the more the merrier. Well, maybe you don't need to overdo it, but still at least 3 must be done. So you click start here, and the runs have already started. So this one, it starts with k equal 1 and the first run. So the k equal 1 would run 5 times, then k equal 2 also 5 times, and so on up to k equal 5 times. Once this process finishes, then we can proceed with the actual use of the structure harvester. In the meantime, while the analysis runs, I would use the time to tell a few words about the Neogen company who are kindly supporting this video. Well, Neogen is a company that provides an extensive range of high-quality, cost-effective, and customized genotyping and sequencing solutions and services for a wide range of species. Neogen has an extremely efficient state-of-art laboratory based in Europe, offering rapid turnaround times to empower your research-based decision-making. Neogen's high-quality array portfolio provides efficient testing to develop targeted predictions and research opportunities at an affordable price. Its custom GGP chips combine outstanding design and evenly spaced coverage of the genome with the SNP parentage marker and causative content. Key drivers behind all of Neogen's new chip design include unique SNP select software and a multiple objective local optimization or MOLO algorithm enabling Neogen to choose the best set of SNPs with optimal genome coverage, recombination rates, and minor allele frequency representation. What's more, Neogen also genotypes on Illumina or Axiom public consortia and custom arrays on behalf of their customers. The future of genomic innovation is here with Neogen's DNA sequencing capabilities. Neogen has been a leader in the innovation of whole genome sequencing, which offers the most detailed view into your genetic program by evaluating every base in the genome and navigating the complexity of genomic variants that make individuals unique. Neogen also provides ChIM-seq sequencing with imputation for select species to augment genomic selection strategies currently in place, in addition to a new technology called InfiniSeq. Combining Neogen's first-class laboratory services with Ginkgo's imputation pipelines and advanced analytics platform, InfiniSeq delivers the necessary insight to confidently select superior individuals from breeding populations and research objectives. With Neogen, customers can also purchase whole flow cells and send them their libraries. The Neogen team is ready to assist with any genotyping or sequencing project, whether it is current or only in the planning stages. Also, a good news is that the viewers of the Genomics Bootcamp or whoever are informed about this possibility can also get monetary benefits in the form of a special offer from the company. So Neogen would like to offer viewers of the Genomic Bootcamp £100 off £1,000 spent on genotyping on their GGP arrays. So if you spend more than 1,000, you get 100 off. What you should do for this is only to fill out the form that is linked below and also quote Genomics Bootcamp in the comments for this offer to access it. So don't miss out on this opportunity. So thanks again to Neogen for their kind support. And now back to Structure Harvester. The Python scripts for Structure Harvester could be downloaded from GitHub. So you just go to the GitHub page of the author and to the page Structure Harvester, where you can find the actual scripts and some description how to use it. But, well, we will just demonstrate the use of it, and especially with the Evano method in this video. So the Python script that you actually need is the structureharvester.py. So you just download this on your hard drive, and well, we would start it with the Python. You open your command prompt and, well, first thing to test if you have Python installed in your computer. So this is, well, a programming language that needs to be actually installed before you can use it. So if you, well, the easy way to test this, so you open your command prompt, and anywhere in that command prompt, or just doesn't matter in which folder you are, basically you just write Python. If it comes back with an error message or something else than Python 3, then, well, you need to install that first. So if you get something like this, so that is the command prompt switches into a Python console, then you are good to go. If you get stuck in the Python console, as I did a few times, so the way to exit is you need to write quit and opened and close brackets, and then you actually get back to the normal command prompt. So you will use the Python script directly. So, well, you don't need to actually enter Python to do anything. The use of the structure harvester Python script is fairly simple. So you have to, well, basically we will write Python here, so that to start Python, then the structure harvester.py is the script we want to use. And it has a few options or few things to consider. Basically, the first thing is the --dir equals, and it should be the results directory from your structure run. So actually you need to put the full path there. And the second thing to add is the --out equals. So this is the output directory. So the directory where your results of the structure harvester would go. So these will be text files. And, well, this directory, if it doesn't exist, it will be created. So you don't need to worry about specifying an existing directory. And then afterwards, you put the options. So we will consider right now the --evano to run this evano method. And it will be, the results will be written into the evano.txt file. After some time, the structure jobs are ready, and you get a nice job is completed message, which is, of course, great. We click OK, we click OK. And now we have everything ready to go forward. So you have Python installed and you have downloaded the structure harvester Python script. So what you need to do is to navigate to the place on your hard disk where the structure harvester script is located. For me, this is, well, this directory, but of course for you is something else. So you use, well, in Windows, the CD for change directory space and the path to the actual directory where the things are located. To check on the help files, or basically the options, and also to check if the structure harvester Python script runs properly. So I would suggest to use this first command, is that you say Python and then space structure harvester.py and space --help. That would print the help file, or, well, not a help file, but some text with the descriptions how to use it. So this is actually exactly what we've discussed before. If you see something like this, so with the options and other things displayed, so you are on a very good way. What you need to do is, well, identify the directory with your results and then just decide where you want to put the results. You can type directly into the command prompt, but I always suggest to put the scripts in a text file first. That way, if you make a typo or you want to reuse the same line at any point in the future, you will have a much easier time. So this is what I did also. So this is actually the last line here, which is, well, relevant. So we start the same way as before, Python structure harvester.py. So --dir equals, and then I put the full path to the structure results. So maybe a bit more detail on this. So there is the project directory within the structure that you have created. So this is the data name. So this is the project name. You see here in the structure up project is this Go Data SEA Alp. So the Southeast African Alpine. And so there are also folders for each run or for each parameter set. Now we use this new set for k-value demo. You open and you see the results here. So there's a results folder. You open just to be sure. So there are all the runs here. So 25 runs because, well, we did 5 k-values, 5 iterations each. So this is the kind of the partial results. And basically you need to put the path to this results directory. So this is exactly what I did here. So this is the goat data, the new set for k-value demo results. So this is the results file or folder that we would use. Then further up dash out equals, and then, well, I just put the structure harvester results also into the same directory, like for the new set for k-value demo, but I created a new folder harvest results. But of course, well, you can use anything that you would like. And most importantly, the dash evano option at the end, because, well, what we want to do is to, well, just compute or kind of run this method. Once we have this line, we just copy it into the command prompt and run it. And well, this the runtime here takes just a second or not even that, and it is ready. Of course, if you get any type of error or, well, anything like that, then you need to check what the problem might be. For example, if you specify the path correctly, or, you know, like if you have the Python script where it's supposed to be, or if you have a Python installed. So all these steps need to be in order. But if everything goes well, you actually don't see anything, any message, just basically the command prompt just jumps to a new line. In the results directory that you specified, then you find the evano.txt and the summary.txt. We are most interested in this evano.txt. So this is actually the results here for all the k-values and the replicates. So also you find some useful information here also in terms of well, links to various places, and also the actual citation that needs to be used for this purpose. For the interpretation of the results, you can check out the mentioned paper, and also I will put the link to this paper into the description of this video. So this is the Structure Harvester website and program for visualizing structure output and implementing the Evano method. So this is the paper to check out. And more importantly, so there is, of course, well, a description how it works, but also the graphs that actually creates. Now, this is just a text output. So in this case, you need to create these graphs yourself, but you would recognize the actual inputs. So these are the k-values, and then on the y-axis are the actual outputs from the evano.txt. So there is this, you know, the mean, estimate, ln, probability, and then it's basically this column. And then if you go further down, there are more well, graphs. So this one, L prime K, and all the others, and also the delta K, that is actually quite useful to determine which K value would be the best. And here, the one that is kind of jumps out to the highest point, or there is with the maximum value, that is the best one to go for. You can use the visualization method of your choice for these graphs based on the output from this evano.txt. Here, the delta K value, that is the last column. So according to this, in this particular set, the K equal 3 seems to be the best. But of course, remember that this run was just very quick with a very, very low number of iterations. So I would not take these results as final for sure. And then for a proper analysis, I would rerun these with a much higher number of iterations in the structure itself. And then checking out the results for those proper runs would be much more informative. So then that was the updated information on the structure harvester and how to deal with this issue without the structure harvester website. Well, I certainly hope it will come back and will be operational soon because, well, frankly, that is just a more convenient way to do things. And also you get these graphs straight away. So that is, of course, great. But until that time, you can also run the Python script and get the results via this approach. From my side, this was it, what I wanted to discuss. I hope you found this information and video useful. If yes, click like, click subscribe, and well, check out the other videos on the channel. But as of now, I would like to just thank you for your time and also wish you a very nice day.